Hello and welcome to my second video project where I will be presenting the issue of ocean acidification. While most people are well aware of global warming due to an increase of carbon dioxide in the Earth's atmosphere, ocean acidification is still an issue that most people are not aware of or educated on. So in this video, I will walk us through the basics of why ocean acidification is occurring, what the process of ocean acidification is, and how this is impacting our oceans and planet as a whole. So without further ado, let's jump right in. Since the Industrial Revolution, anthropogenic activities such as burning fossil fuels have increased the amount of carbon dioxide in the atmosphere. Atmospheric carbon dioxide at the beginning of the Industrial Revolution was about 270 to 280 parts per million. In 2019, atmospheric carbon dioxide reached 409.8 parts per million. This is the highest concentration of carbon dioxide observed in the past 800,000 years. Figure 1 shows the linear trend of carbon dioxide in ppm increasing in the atmosphere for the past few decades. These values were recorded from Mauna Loa, Hawaii. Figure 2 shows how in the last 800,000 years, through ice ages, times of lower levels of CO2 concentration, and warmer interglacials, times of higher levels of CO2 concentration, the Earth's natural processes never had global atmospheric carbon dioxide concentrations exceed more than 300 parts per million. These graphs here show how the burning of fossil fuels and increased human activity is exponentially increasing the amount of CO2 in Earth's atmosphere like never before. This sudden increase in atmospheric CO2 has a direct link to an increase in CO2 dissolved in our oceans. This is due to Henry's law. Henry's law states that at constant temperature, the amount of a given gas that dissolves in a given type and volume of liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid. Based on this law, if atmospheric CO2 continues increasing at this linear rate, predicted to be about 2.5 ppm per year, the amount of dissolved CO2 in our oceans will continue to increase as an equilibrium is trying to be reached. 1/3 of the CO2 emitted annually into the atmosphere is dissolved into our oceans. An increase of CO2 in our oceans causes a decrease of pH, which makes for a more acidic environment. Carbonic acid is a product of water and carbon dioxide when mixed together. That carbonic acid can rapidly dissociate and make bicarbonate by losing one hydrogen ion. Bicarbonate is also an acid and can further dissociate into a carbonate ion by losing another hydrogen ion. Carbonate ions can interact with other ions such as calcium and magnesium to form calcium and magnesium carbonate. Carbon dioxide concentrations in the ocean alter the concentrations of other compounds, such as calcium and magnesium carbonate, and this is called the carbonate buffering system. This helps alleviate the atmosphere of the large amounts of CO2 now present due to the burning of fossil fuels, but in turn greatly affects the pH of our oceans. The pH of the ocean's surface waters was 8.21 at the onset of the Industrial Revolution. Now it's 8.1. It's important to remember that the pH of a solution is the negative log of the hydrogen ion concentration in a solution. And since the pH scale is logarithmic, this 0.1 drop in the ocean's pH means a tenfold, or roughly 30% increase of acidity. The more hydrogen ions there are in a solution, the more acidic the solution is going to be, and the pH will just decrease. Excess hydrogen ions that are contributing to this decrease in the ocean's pH are due to an increase of CO2 aqueous. As acidity increases, available carbonate ions bond with the excess hydrogen ions, which results in fewer available carbonate ions for calcifying organisms to build and maintain their shells, skeletons, and other calcium structures. When the pH gets too low, there's a real possibility that shells and skeletons will begin to dissolve in our oceans. This threatens the entire oceanic food chain, and therefore threatens a huge source of food for humans as well. However, the disassociations involved with the carbonate buffering system are reversible. Per Le Chatelier's principle, the amount of CO2 depends on if the reaction moves towards the left or the right. We have the power to decrease CO2 emissions and help reverse the damage humans have inflicted on the oceans. While the damage is reversible, it will not be reversed on its own. It is up to us and how we as a society move forward and change our actions when it comes to fossil fuel consumption. There was a study done examining the effects of pH on pteropods, tiny sea creatures that make up the diet of whales, salmon, etc. When the pteropods were introduced to an environment with the pH and carbonate levels anticipated for the year 2100, their shells dissolved over a mere 45 days. The future of our oceans and our food supply relies on making environmentally sound choices now to decrease the amount of CO2 emissions in our atmosphere as to decrease the amount of CO2 dissolved in our oceans per Henry's Law. It is imperative that we maintain an oceanic alkaline pH suitable for keeping our marine life healthy and strong for the years to come. Here are my sources and links for all of the pictures used in this presentation. I hope you enjoyed learning about ocean acidification, and I hope you have a great day. Thanks.